Graph of a function. The graph of a function is a visual representation of that function. Steps to graph function. We start with setting up a table as shown here. We start with x and y value. We choose different x values depending on the domain we are allowed to use x values, and then we calculate the y values for those x values. Arrange the table so that the values of x is increasing. That's easier to plot it that way. If you do it in any order, that's okay too. Okay. Then we plot the points and then join them from the left to right by smooth curve. Okay. We do not use straight lines between the segments. Some restrictions, some warnings to remember is division by 0 is not defined. So whenever we have a function which is a rational function with denominator having x there, we have to decide which x's we cannot choose. Only real number values of the variables may be used. Any place that the graph changes in a way that it's not expected, we should go back and check in case we made mistake. We could have made mistake sign wise or number wise. Okay, let's start with first example. It says graph the following functions. The first one is y equals 2x plus 3. Because it has no x square, no x cube, it is just simple x plus 3, no square root. It is going to be an equation of a straight line. So we can pick any x values we like, but we will be picking x values to be around 0. That's usually the case. So I'm going to say, let's pick x to be, let's say -2, -1, 0, 1, and 2. For the y values then, you actually put -2 in here. So you get 2 times -2, which is -4, plus 3, which will give us -1. Now we put -1 in there. So 2 times -1 will give us -2, plus 3 will give us +1. Now we will put 0 there. 2 times 0 will be 0, plus 3 will give us a 3. Substitute 1 there. 2 times 1 will be 2, plus 3 will give us 5. And then substitute 2 there. 2 times 2 will be 4, plus 3 will give us 7. Okay. Now we will plot this. Ideally, you will plot them on a line paper, grid paper like this. I am going to show you using software, but I want you to learn how to do it manually. Okay. So we'll plot this graph. So we will say y equals 2x plus 3 here. Y equals 2x plus 3. Make sure we label our x's. So you'll label this to be your x-axis, this to be your y-axis, and then you will plot your points. Okay. So the points we have, as we have right here, we have -1, 1, 3, 5, 7 for the y values. So -1, 1, 3, 5, 7. Those are our points. When x is -2, y is -1. When x is -1, y is 1. When x is 0, y 3. When x is 1, y 5. When x is 2, y will be 7. And that will be our graph. And we will also label this graph. We will label it to be y equals 2x plus 3. So we will see right here y equals 2x plus 3. The second one here then, we are asked to graph y equals 3 times x square. Again, we will choose x values. It is your choice where we put it for parabola here because there is no numbers here. So the vertex is 0, 0. So I'm going to put x values to be like previous one. -2 around 0. -1, 0, 1, and 2. So for parabola, we pick values around vertex. In our case, vertex is 0, 0. So when x is 0, y is 0. When x is 1, 3 times 1 square will be 3. When x is 2, 4 times 3 will give us 12. When x is -1, we get -1 square to be +1 times 3 will still give us a 3. And then -2 there will give us 4 times 3, which will be 12. And then we plot this one. So y equals 3x square. Okay. So we'll draw x-axis, we'll draw y-axis. If you notice, the y values are all positive. So when we sketch on paper, we should have no negative y values or very few. We need our graph to have lots of positive y values. So your grid could look something like this basically. Okay, and now we say we will say y equals 3x squared. Okay, so this is our graph, and then we if you were to see the table of values, as we have 12, 3, 0, 3, 12, 12, 3, 0, 3, 12, and then when we plot them, we get something like this. When x is 0, y is 0. When x is 1, y 3. When x is negative 1, y will be 3. And then if you see up here, when x is 2, y will be 12. And when x is negative 2, y will be 12. On paper, we cannot go like this. So we have to make sure our grid is such a way that it fits in all the values in the table. So it should be like this. Or on paper, we should have something like this. Okay. The next one then we have is y equals negative 2 times x plus 1 square plus 3. So what we'll do for x and x values here, again it's crucial what we pick for x values. Because this is a parabola with vertex being negative 1, 3, my middle point here can be x equals negative 1, y equals 3. Then I'll pick two more values to the right of negative 1, which will be 0 and 1. And I will pick two more values to the left of negative 1, which will be negative 2 and negative 3. Now let's try to put 0 in there. So if I put 0 there, 0 plus 1 square will give me 1, times negative 2 will give me negative 2, plus 3 will give me a 1. Now if I put 1 there, 1 plus 1 will be 2, square will be 4, times negative 2 will be negative 8, plus 3 will give me negative 5. On this side now, if I put negative 2 there, negative 2 plus 1 will give me negative 1, square that will be positive 1, times negative 2, which will be negative 2, plus 3 will give us 1. If you're not sure, you can punch in your calculator as well. Similarly, if I put negative 3 there, negative 3 plus 1 will be negative 2, square that will be 4, times negative 2 will be negative 8, plus 3 will be negative 5. And now when we plot this, we will get a parabola, and because of the negative 2 here, it will be parabola opening down. The maximum value we have is negative 1, 3. So when we decide our scale, we need to make sure there are not too many positive values on the y. We don't need too many positive values for the y. Okay. So to graph that, we will say y equals, we have negative 2 times x plus 1 square, and we have plus 3. And then this is our graph we get. And the scale we will use for the table, we will use negative 3 to positive 1. Okay, so we have negative 5, 1, 3, 1, negative 5. Negative 5, 1, 3, 1, negative 5. If you notice for parabola, from the vertex, the values on the left for the y has to be same as values on the right for the y values. They have to reflect, and that's seen in the graph too. They reflect from the middle line, which we call line of symmetry. So here and here, these 2 points reflect, here and here, these 2 points reflect. Those 2 points, calculation wise, we don't need. Those are the x-intercepts. We can just focus on these 5 points. 1, 2, 3, and 4 and 5 on paper.